Robert Triendl is General Manager for Japan at Data Direct Networks, and he's got the greatest collared shirts. It didn't work at a restaurant in New Orleans, but that's another story. Ladies and gentlemen, Robert Triendl.
Thanks. Thank you. So this will be one of these other boring vendor talks, but nonetheless try to stay. Today morning at breakfast, somebody said to me, so you have a vision for Lustre, so probably you have visions, you should go to the psychiatric hospital, not to LAC. Well, we have a bit of vision, and the vision, so this community is an important community, but it also has its limitations, and I really think it needs to grow. And I'd like to give some of the directions where it needs to go. So I'm going to talk about the changing markets for Lustre as we see them internally at DDN, about the vision for Lustre that isn't quite Exascale, but it's still important, about building Lustre for future sets of customers, a bit about operational performance, about this boring thing called conventional storage. We sell those things, so I need to talk about it a bit, and about optimizing applications on Lustre. Now, hyperscale storage markets, so you have the HPC market, Scratch, you lose your data, doesn't matter, petabytes, it's all streaming rights, large file, blah, 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 you know all that. And then you have cloud, so it's warm or worn, so write once, read never. Billions of objects, really not files, random read, small files, it's all Ethernet, it's all distributed. And then there is this strange visionary thing that we all believe or don't believe in, which is sort of the big data analytics side. The reason why I talk about it is very simple. This is our customer set today. It's about 30% is classical HPC work. About 33% is really data. So people who store their data, keep their data, analyze their data in Lustre. And then there is something called a mixed, which is mostly universities, and they do all sorts of things, including very strange things. So somebody says, so I run my application on this supercomputer, and it's 10 times slower than on my PC. And maybe your file system is the reason for that. That may happen. And there is a small and growing market that's cloud. And there is always sort of a piece of Lustre that's really archive. So some people do use Lustre as archive. And this is real data. This is how our Lustre market looks like today. And as I said, there are many different applications, of course, the traditional applications on work, some newer markets like CAE and chemical. There is the tier 2 Lustre in the HPC centers. Then there is some people who use Lustre as a backend for clouds. HPC clouds, and then there is sort of the general academic market with all these people like Steve who have lots of different customers do many different things. Then there are new markets like genomics, and I remember a conversation 4 or 5 years ago in Japan with one of our largest genomics customers, and Eric Parton, who sits here, and it was like, so what are you guys doing with Lustre? So yeah, we have all these small files, and but that is an important segment of the market today. There is what I would call big data science. So everybody who has large data sets in research, all of that is data, and it's usually not so much MPI, it's really analytics. There is energy or oil and gas, as we heard. There is security, or people who do things like image analysis on Lustre. And there is people in finance who use Lustre today for things like analysis, data analysis. Now, that's the reality today. And all of these, and as we heard in earlier talks, all of these markets, and if you pick out segments, have different types of requirements, and I won't go into details. And they're all a bit different. The market sizes are different. Some of these customers have been used to NetApp, or there are customers who have 50 petabytes of Isilon on the floor, and that go talk to that storage administrator and try to convince him to buy Lustre. That's going to be a difficult conversation. But this is the real reality. This is how our market at DDN, and I think we still have the largest and most diverse customer set in the Lustre market, has changed over the past few years. So you can see it's mostly now in the red and orange part. So the Lustre work as part of the market is decreasing. The archive is kind of, it's there, but really the action is around data analysis, mixed workloads, and that's the reality today. And I'm not so sure whether that community is really well represented in the room here. It's starting a bit, but I don't think that this community is doing enough for this part of the market. This is how our market has changed for the last few years. So 4 or 5 years ago, there are very few users in the industry. Today, that's a fairly important part of the market, and it is growing. Now, the focus for Lustre has been so much on performance over the years. So you have these disk drives that get bigger and bigger, and today we get 100 megabytes per second out of a drive. Soon it is going to be 140, 150 megabytes per second. At the same time, and that's the blue line, the IOPS per drive is decreasing. So you're going in the direction of a market that is a decreasing market, because that works for work and throughput. It doesn't work for a genomics customer, for certain. So the things that at DDN that we really want to do is care about that middle segment of the market. So end users that are not just the very large sites, but end users who have really interesting data problems and help solve these end users with usability features, with much more built-in reliability and availability, better recovery, features for these broader markets, and also performance for this much broader set of applications. So it's no more just IOR throughput. It's a lot of different applications, and you really actually need to go down and sit down and look at those applications, what you're doing, and then optimize Lustre for those applications. This is not the latest version, but we are contributing more to the Lustre community for sure. And I'm not saying that our competition, I've excluded Intel, otherwise you wouldn't see anybody else. I'm not saying that our competition is gray and colorless and boring, but if you want to read it into the slide, feel free to do so. So this is our sort of Lustre stack overall. So we do support Lustre on DDN storage or on other hardware, whatever you want, from our friends at Dot Hill, or from our friends at Seagate, or from our foes at EMC. We use mostly Intel as our backend support, so everything you buy from DDN is either Intel Enterprise or potentially for some customers Intel Foundation. We are certainly looking at OpenCFS. We're also looking at BtrFS, and I'll talk about this later in a moment. We do have our own Lustre edition based on Intel Enterprise that has a number of enhancements, and I'm certainly willing to talk about these if you're interested. We have our own client that is optimized. We have different sets of clients for different customers. We use Intel IML for monitoring, but we have also our own monitoring tools, and there is a whole set of tools on data management that we're working on. And I'll explain some of these projects just shortly, so I'm running out of time. So why BtrFS? So one is it's a standard local file system in Red Hat 7. It seems to have better throughput performance than CFS. It has a similar feature set, but it's all Linux. There is no Oracle or NetApp that will sue you, and we're a mid-sized company, not a small or large company, so that's a real issue. And again, go to that 50 petabyte industry customer and try to sell CFS. And it will allow simple integration and deployment, because with CFS I can no more sell an image file. I have to tell my customer this is CFS, and you know, this in the installation process you have to do it a bit differently. Something else, application optimized Lustre. So we have started to work a lot on Lustre for specific applications and on workload profiling. and on optimizing across I/O calls. So one area, for example, is mapped I/O. So any genomics customer will have a lot of mapped I/O. So we have a client that does mapped I/O a lot better than the standard clients today. And then it's really about optimizing the application runtime, not just the I/O. That's what customers want to see, and to do that, you really have to work with customers. This is an example from a customer in the genome industry, where just shifting from one client to a different Lustre client reduces application runtime for a very general application by about 20%. Well, it's a lot of servers, potentially. The other area that we are really interested in is SSD pools and SSD caching, and we presented some of that work last year at LAC, so I'm not going into details. We are working very closely with Intel on integrating DSS as a link from the file to the block layer. We want to really build those things into the file system and use that as a way to increase small file performance across the board. And also increase random read performance to large files, which is also a very important application workload. And we have a bit of application additional specificity built in the Lustre versions we distribute with an F-advice call that can be issued from a client. So you can tell the Lustre file system to take a list of files and put them into either the rate controller cache or the OSS cache. We have one presentation later, I think today, about monitoring from one of our customers. So there's a little tool that we have built. It uses open DSDB with HBase. It's very scalable, and I'm not going to talk about the details, but the experience was that you can collect lots of logs. So this is like 64 terabytes of Lustre stats in just 15 days, depending on how you do it. And as I said, Mr. Sato will talk a bit more about that. CFS is not quite sort of the deep impact that will destroy the dinosaur rate controllers. So I need to talk a bit about that. So block level rate still has really good mixed I/O performance. It has consistent performance. It has hardware optimized performance. It has probably best performance during failure, and it has integrated storage services, of course, all those things. And we have a rate stack that is really, really efficient. So with only 8 CPU cores, we can do 1 million 4K read IOPS. We can do, with the same 8 cores, at the same time, we can do 10 gigabytes per second. And those 8 cores are sufficient for the entire PCI infrastructure, which is why in our next generation product, we will have an extensive PCI network inside the box to go beyond sort of a traditional x86 PCI architecture. And you get more cores, so you get more file cores for file system services, and you get additional cores for additional functionality. This is just sort of general data, so the SFA rate stack, and it isn't just a box, it's really a software rate stack, has a really excellent random read performance, just one performance characteristics, and just throw it out. And then being DDN, sort of, I think one thing we do well is flexible SSU design, so you can go from small to mid-size to large to extra large in any way you want, and that is probably really something that the company offers. This is sort of the latest iteration of performance SSU. It's about 45 gigawatts per second per rack with 4 to 8 OSSs and 2 to 4 MDSs and the usual monitoring, etc. Stuff. And since all you guys really hate hardware, I put up some hardware slides. So this is how the hardware looks like. As I said, it has an extensive PCI network. Sorry, there's a slide for Steve. It has a very extensive PCI network inside the box. It's a 4U box. And it has on the back end 48 slots for PCI connected NVMe SSDs. So you can get 60 gigabytes per second out of those 4Us. And this is my slide for Steve, of course. Thank you. Any questions? So then lunch is wait. Oh, yes.
Please speak into the microphone.
I'm learning.
No, you've cursed yourself.
Yeah. Could you just go back to the slide that shows your contribution?
Oh, yeah, that's going to take a lot of clicking, I guess.
Oh, it's too difficult.
But why?
So, yeah, you know, what is your attitude towards future contributions from DDN when we actually have a community-managed source tree?
So
that has been discussed extensively.
Yes.
So, what is your corporate position?
So the corporate position is that everything everything that we do, we give back to, and that is within the range of the GPL license, we do give back, and we do give it back in time, not 5 years later. That's a simple position. And today the vendors play a bit the game and say, yeah, I'll give it back in a year, and then it becomes 2 years or 3 years. And sure, there is a period of time where we have testing, etc., etc. But in principle, all of the work we are doing internally, we will give back to the community. Any other questions?
Yeah. So, you know, Brent was here. He said that, you know, enterprise is going to be available through respective, you know, partners and vendors.
Yes.
Is that the case with you guys?
Anything you buy from DDN is going to be Intel Enterprise supported. Yes.
Okay.
And there is the Foundation Edition that is also available if you run OpenSFS Lustre. So, but in principle, the bias is towards enterprise.
And that would entail, you know, having the monitoring tools as well?
Yes.
Okay.
That's all. I mean, there is no additional cost for that.
All right.
Yes.
Anyone else? Okay. Thank you, Robert.
Thank you.